Once upon a time, there was an astronaut who loved to play musical instruments. So when he went to space, he took his favorite musical instrument along with him. Now, one day in space, he was getting bored. So he took out his favorite musical instrument and he started playing it. But to his disappointment, he found that he could not hear the sound of the musical instrument. He was heartbroken. He thought that the instrument was damaged. But when he came back to Earth, he played the same musical instrument again. And to his surprise, he found that this time he could hear the sound of the instrument. Don't you think it was weird? Why couldn't the astronaut hear the sound in space, but he could hear it on Earth? Let us find out from a simple experiment. In this experiment, the apparatus used is a glass jar, two tubes, and an electronic buzzer. You will notice that once the buzzer is fit with the battery, it is kept inside the glass jar. Now, the moment it is inserted into the glass jar, you can hear the ringing of the buzzer. You will also notice the structure of the two tubes. One of the tubes you will find is attached with a vacuum pump, and the other tube has a valve. Now notice, as the air from the glass jar is gradually sucked out using the vacuum pump, what do you observe? The ringing of the buzzer diminishes gradually until a point comes when you cannot hear the ringing of the buzzer at all. It completely disappears. Isn't it surprising that even though the buzzer can be shown to be ringing, you can't hear it? Now let's see what happens if the air is allowed back into the glass jar. The air is allowed back through the second tube once the valve is opened. Now you see, the moment air is let inside, the ringing of the buzzer can be heard again. So what did we find? When there was no air inside, the sound could not be heard, but when there was air, we could hear the sound. So what can we conclude? That sound can travel through air. Now, sound can travel through air, which is a gas. Can sound travel through any other media? Let us find out. Lay your head down on a table, as you see in this picture, and put your ear on the table and scratch the table with your fingers. You will notice that you are able to hear a very distinct sound. Do you know where you hear that sound from? That sound is the sound traveling from the table to your ears, where you're scratching it. And the table is a solid, thus sound can also travel through solids. Now we learned that sound can travel through solids and gases. Can it travel through liquids? Let us perform another simple experiment to find out. Take a tub and fill it with water as shown. Lay your head on the side so that one of your ears touch the surface of the water. Now with your hand, take a bell and dip it into the tub and then ring it. What will you observe? You will find that you are able to hear the distinct sound of the bell ringing. Can you tell me how that sound travels? That sound of the bell travels all the way through the ring, through the water, and to your ears. So what did we see? That sound can travel through gases, solids, as well as liquids. But then why could sound not travel in space when the astronaut was playing his musical instrument? Let us find out. You know that in space, there is no gas anywhere around. There is no medium anywhere around. So when the astronaut was playing his musical instrument, there were no particles to carry the vibration to his ears. Now, what happens when there are no medium particles surrounding? If there are no medium particles, how do you think the disturbance will travel from the strings to the astronaut's ears? We have learned that when there is a vibration, there is sound. When vibration occurs, the medium particles vibrate back and forth, and in this way, the disturbance travels. But if there are no medium particles, then the vibration will not be able to travel, and thus there will be no sound. So now, if there is no sound, how do you think astronauts in space are able to communicate with one another? You must have seen in many movies that astronauts, when they are in outer space, are able to talk with one another. But if there is no medium to carry the disturbance, how do they communicate? Let me show you an interesting clip from the movie Gravity, and then you'll understand. In this clip, you will notice that Sandra Bullock and George Clooney are able to communicate with one another even though they are in space and they are a considerable distance apart. How do you think it's possible?
Just hold on, and I'm gonna start pulling you in.
Hey, Doc.
Just hold on, hang on. I am gonna pull you in.
Ryan, listen.
Pull you in.
You have to let me go.
No.
The ropes are too loose. I'm pulling you
No.
with me. You have to let me go, or we both die.
You go, we're fine.
Astronauts in their spacesuit have a special device which is responsible for converting sound waves into radio waves. Now, radio waves are electromagnetic waves, a special kind of waves which do not require a medium to travel. Thus, in space where there is no medium, converting sound waves to radio waves, astronauts are able to communicate with one another efficiently. So, in this discussion, what did we learn? We learned that sound can travel through air, through liquids, and through solids, but it cannot travel through vacuum. So, what does that mean? Sound requires a medium to travel through. But in space, astronauts are able to communicate with one another through the use of a special device in their spacesuits. That device converts sound waves to radio waves, and thus astronauts are able to communicate with one another.